Okay, Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. So today we will going to study chapter 4, which is reaction mechanism. So in this chapter, there are several subtopic here. So you need to know what is the definition of the rate, what is called as a rate law, rate constant, and we need to know how to measure the reaction order and determine the rate law of the reactions. So from there, we need also need to know the reaction mechanism, what is half-life, and we need to know how to apply the equations, activation energy, action parameter, and the transition state theory. Okay, what is meant by the rate of reaction? Okay, according to the chemical kinetic, which is the rate of reaction is related to the speed or rate which the reaction occur. Okay, which is kinetic, which is referred to the reaction rate and the change in the concentration of the reactant or concentration and the formation of the product, and the unit is in the molarity over time. And then the rate of the reaction is always positive. So normally the rate of the reaction is expressed in terms of change in concentration with time, and sometimes it's also expressed in terms of the change in pressure, especially for the gas. The normally it expressed in the pressure lah. But for the liquid, it expressed in the change in the concentration. So from the figure here, you can see that the formations of the product B from the reactant A. So initially the A, which is in black color at the time 0, then when the time increase, so the formations of the product B, which is the red color, so we can see that the concentration of A is reduced while the concentration of B is increased with time. So we can determine the rate of the reactions is equal to change in concentration of A over change in time, and also equal to the formations of change in concentration of the B, product B, over time. Okay, why you need to know the rate of the reaction? Actually, the rate of the reaction is important to know because you need to know how fast the reaction occur, so you can determine the how many energy need to for the process to occur, and also for example, you want to know the degradation rates of the species, so you can determine the shelf life of the products. So this is why it is important to study and relate it to our daily life. Okay. For example, the decomposition of hydrogen peroxide as shown in these chemical reactions. So you can use the manometer to calculate or to determine the reaction rate of the from the reactant to produce products. So you can measure either the change in pressure or concentration using the ideal gas equations. So from the figure, you can see that the pressure versus the time for the decomposition of hydrogen peroxide. So the rate is equal to the change in the formation of oxygen over the time, and also equal to when you uh, use the ideal gas equation, PV is equal to nRT, so you can change the concentration. N is equal to I over RT, change in P over change in the time. Then the instantaneous rate for the decomposition of hydrogen peroxide at 400 degrees Celsius given by the tangent or slope of the graph, which is change in P over change in T, and multiply by 1 over RT. So the rate law can be expressed. For example, you have a reaction between A and B. to produce C and D. So the rate of reaction is equal to 1 over A, change in A or change in T, and also equal to negative 1 over B, change in B over T. Okay, for the reactant, the sign should be negative lah. And then for the product, the sign is positive due to the formations of the product. Okay, the rate law for the reaction express the relations of the rate reaction of the rate constant and the concentration of the reactants raised to the some power, and then from there the rate of reactions is proportional to the concentration of reactant and the rate constant. So rate is equal to K concentration A power X and concentration B power Y, which is X is not equal to A. A is a stoichiometric reactions and Y is also not equal to B, which is the reaction is X order in A and Y order in B. So the overall order is equal to X plus Y, which is X and Y is not a stoichiometry of the reaction. Okay, which is means that this is determined by the concentrations of the species A and species B. Okay, X and Y is number that or that must be determined experimentally. So the overall reaction is the sum of the power, which is X plus Y. So from the rate equations, which is for example, rate is equal to K. K is the constant, A is the concentration of the species A, and B is the concentration of the species B. X and Y is the order of the reaction, which is respective to the A and B species. So rate law is express the relationship of the rate of the reactions to the rate constant. Rate constant is K, and the concentration of the reactant raised to some power. If you remember that you already done experiment to calculate the rate of the reactions, so you use this equation to calculate the order of the reactions, which is it is related to the concentration. It is measure how is it the concentration can give an effect to the rate of the reaction. Okay, for case 1, consider these equations A plus B to produce C and D. So let's say the rate is equal to K concentration A and concentration B. So the overall order here is equal to 1 plus 2 or equal to 3. Okay, let's say the concentration of A is equal to 1 molar and B is also equal to 1 molar. So when you double the concentration of A from 1 to 2 molar, what happened to the rate of reactions? So from these equations, so you can enter this value, so you can get that the rate of reaction will also double when the concentration of A is increased to 2. So from for the case 2, you can see that when you increase the concentration of B from 1 to 2 molar, so the concentration, so the rate of reaction will be increased by 4. Okay, consider case 2, which is the reactions is 0 order in A and first order in B. So means that the overall order is equal to 0 plus 1 or equal to KB. Means that the concentration of A means that the is not involved or is not affect the rate of the reaction. Okay, the rate of this reaction is independence of the concentration of A. So from this we can summarize that the rate law is always determined experimentally, and then the rate order and the rate constant of the reaction is determined from the concentrations of the reactants. Okay, not concentration of the products. And then the order of the reaction is not related to the stoichiometry or of the reaction, okay, based on the overall balance equation, but it is just related to the concentrations of the reactant. Okay, the relation between the reactant concentration and time for zero order reactions, which is from the reactant A to produce a products. Okay, actually the zero order is quite rare in formations of the products. So the rate of the reaction for the zero order is equal to rate is equal to K constant times to the concentration of A power 0, which is A power 0 is equal to 1, so means that rate is equal to K. So the rate of the zero order reactions is is equal to concentration of A at time t minus to the initial concentration of A equal to negative kT. So when we rearrange these equations according to a straight line curve, which is y is equal mx plus c, so we will uh, construct a curve which is concentration of A at time t versus t, so we can get a straight line with the slope is equal to negative k. Here the k is in unit mass over volume time. So the half-life for the zero order is T half is equal to A naught over 2K. Okay, what is means by half-life? Half-life is defined as a time required for exactly of the half of the entity to decay on average. Okay, why it is important to determine the half-life of the products? It is because it can enable us to determine when a sample, for example, when a sample of the reactive material is safe to handle. For example, here, the decomposition of the nitrous oxide with the presence of the platinum.